Alright, Algebra 2, here's the lesson on compound events in case you're still confused on it or missed the lesson. What we are learning about when we're talking about compound events is more than one event. Compound literally means more than one. So a compound in chemistry is made of more than one element. A compound word is made of two words put together, like underground, under and ground. So it involves two or more events. There's two different probabilities. We might see a probability and, which looks like this. Make sure you know that symbol. And then we might also see a probability of something or something else happening. And that's going to look like this. There's two different types of compound events. There's mutually exclusive events. Mutually exclusive literally just means events that can't happen at the same time. So for instance, you can't be both 17 years old and 18 years old at the same time. You also can't be both in Minnesota and in California at the same time. Those are mutually exclusive. But the nice thing about mutually exclusive events is that it's really easy to calculate their compound probabilities. So for instance, if we said that the probability of a random central student being in ninth grader is 0.31, meaning 31% of the school is a ninth grader, and the probability that a random central student being a senior is 0.22, meaning that 22% of the students at Central are seniors, we could find the probability of both of them, of being both at the same time, or the probability of being either one of them. Well, the nice thing about mutually exclusive probabilities is that the probability of being both mutually exclusive events is always the same. Can you imagine what that would be? Think. What's the probability that you're both in ninth grade and in 12th grade? It's impossible, so the probability is 0. That's the case with all mutually exclusive events. However, when we find the probability of something or something else happening, it's also very simple. All you have to do is add the two. You have to say, okay, well, there's 31% are ninth graders, 22% are 12th graders, so you just add the two up. It's going to be 0.53 or 53%. So here's the rules. Mutually exclusive events have an and probability of 0, and they have an or probability of whatever you get when you add the two different things up. Now there's also something that where we have non-mutually exclusive events. The name of these are inclusive. It's the opposite of exclusive. Inclusive. So for instance, if you have 2,000 students at Central, 1,040 of them take Spanish, 440 of them are seniors, find the probability that somebody is both in Spanish and a senior, or in Spanish or a senior. Now the problem here is that there is some overlap. It may be that maybe 100 of these seniors are in Spanish, or it could be 400 of them are in Spanish. We don't know. We don't have enough information because these are not mutually exclusive events. If we know that exactly 10% of the seniors are in Spanish, then we can solve this using what's called a Venn diagram. Here's a Venn diagram here. You make these two circles where each section represents something different. This red section here, the red circle in its entirety represents all seniors. However, the red section alone only represents the seniors that are not in Spanish. This section, this purple section, represents seniors who are also in Spanish. And then this blue section over here represents people who are in Spanish but not seniors. Okay? So we're just going to figure out what each of the numbers are so that we can find these probabilities. Well, from the previous information, we know that there are 440 seniors and 10% of them are in Spanish, so we would put a 40, sorry, I'm going to use a different color. We're going to put a 44 here because that's 10%. 10% of the 440 seniors is 0.1 times 440, which is 44. That's where I got that from. So that means, since we know that there's 440 seniors, that means these two sections should add up to 440. So we're going to have to do 440 minus 44, which is 396. We know that there's 1,040 people in Spanish, and again, that was given in the problem. You can rewind it if you want to double check that. So I would have to do 1,040 minus 44, because these two sections should add up to 1,040. So we get 996. Last but not least, we want to find how many people are not in both, just so we can have all the categories. So we know that every section should add up to the total 2,000 students, so we have to do 2,000, take away the sum of these three things. So let's add those up. 396 plus 44 plus 996 is 1,436. Take that away from 2,000, and you get 546, or 64. This is where we put it as on the outside. Now, when it asks us what is the probability of both being a senior and being in Spanish, we can say, oh, we know this is the and section here, so it's just 44 out of 2,000. There's a common mistake that people make is that they think, oh, I'll just put 44. But remember, it's out of 2,000, which is 0.022, which is 2.2%. Now, the probability that you are a senior or in Spanish is what we get when we add all of these three categories up. Because if I said, you know, I'm a TA, or I'm a teacher, and I teach Spanish, so I want my TA to either be in Spanish or to be a senior because I trust the seniors. Well, then these guys, all these seniors, would definitely be okay. And so would these guys here who are seniors and in Spanish. They'd be especially good. And so are the people who are in Spanish but not seniors, because I said I'll take a TA as long as they're in Spanish. Okay, so we have, add those up, we get 1,436. So it's 1,436 out of 2,000, which is 1,436 divided by 2,000, 0.718, which means 71.8% of the people are either seniors or in Spanish. And that's it.